Developers write computer programs to work with data. Data is gathered, analyzed, stored, processed, shared, and reported. We use variables to store our data in a named reference that we can refer to later in our code. Let us first examine a simple Rust code. Notice that Rust is a braced language with statements terminated by semicolons. Second, Rust intentionally mimics as much syntax from other languages as it can, C and Python in particular. So it should feel familiar right from the start for a lot of you. In Rust, a variable is declared with the keyword let. Each variable has a unique name. When a variable is declared, it can be bound to a value, or the value can be bound later in the program. Here we declare a variable, apples, and initialize it to the integer value of 5. But as we already know that, Rust is a strongly typed language. So where is the type annotation? Whenever Rust can figure out the appropriate type itself, you can leave the type annotation out. There is no need to write any special keyword for it. Rust do it automatically for you. When you do, annotate the type, it looks like this, a colon after the variable name, and then the type. I32 is a signed 32-bit integer. We'll talk about primitive types in the coming videos. That's how you initialize a single variable. It just so happens that the let statement has a trick up its sleeve. It allows us to initialize multiple variables at once. A let statement can destructure the data on the right-hand side and use it to initialize variables inside of a corresponding pattern on the left-hand side. Here Rust will initialize apples to a value of 5 and oranges to a value of 9. In Rust, variable bindings are immutable by default. When a variable is immutable, after a value is bound to a name, you can't change that value. It is unlike other programming languages. Most languages default to variables that you can change. Why would Rust have immutable variables by default? And the answer is safety, concurrency, and speed. There are lots of bugs that won't occur in the first place if a value never changes. So safety is improved by immutability. Data that never changes can be shared between multiple threads without worrying about locks, so concurrency is improved by immutability. The compiler can also do extra optimizations on data it knows won't change, so speed is improved by immutability. That's why data is immutable by default in Rust. But we do not live in an ideal world. Sometimes we need to change the value of a variable. We can't just change the value of apples as long as it is immutable. If we try to do it, that would give us an error. This error, in fact, here's our very first example of our Rust compiler. Let's break down this information. At the top we have a summary of the error, cannot assign twice to immutable variable apples. Next we have the location of the error, source main.rs, line 3, column 5. Then, most amazingly, we have a contextual explanation of what we are doing wrong and how we might fix it. On line 2 we initialize an immutable apples to the value 5. Therefore on line 3 we cannot assign a different value. Immutable means you can't change it. What does the compiler suggest? Make the variable on line 2 mutable. If this information isn't enough to figure out the error, there is also a full explanation of this error type that you can get by running this command. You can go ahead and run this command right now if you like. Rust C is the actual compiler that Cargo uses under the hood to compile your code. Here's a version of the code that will work. It looks like this. Adding a mutable keyword, mut, before the variable name make the variable mutable. So we have mutable variables that we can change and immutable variables that we cannot change. But there is also another kind of variable that is even immutable, the constant. There are 4 things different about declaring a constant. First, const instead of let. Second, the convention is to use screaming snake case for constants, meaning all uppercase words separated by underscores. Third, the type annotation is mandatory. You can't just leave it out. And fourth, the value must be a constant expression that can be determined at compile time. So why would you go to all this trouble to use a constant? 2 reasons. First, you can place a constant outside of a function at module scope and use it anywhere you want. A global, an immutable, constant. Second, because const values are inlined at compile time, they are blazing fast. In the next video we'll talk about scopes.